This is 300 plus academy, where all we do is exams, tutoring, ensuring that you ace your next exam. Okay, still on the subject matter, chemistry alternative to practical for the general certificate examination. I will bring to you another probable question here. This question here talks about a redox titration, different from the normal, because in your burette, what you have in there is your potassium permanganate. That's potassium tetra ozomanganate 7. And what you have in your, what you will be pipetting here talks about your iron sulfate hexahydrate solution. Quite bulky formula for what we are going to be pipetting, talking about solution B, as you can see displaying on your screen. So getting straight into the question. So it doesn't necessarily have to be acid and base. In a redox titration, you are talking about your oxidizing agent and your reducing agent. So this is a redox titration, although this is going to be the alternative to practical way. So looking at the question popping up on your screen, the first thing we're told to do is to complete the table. We all know by now that usually we will have an initial burette reading, then we run whatever solution we have in the pipette, giving us our, until we, of course, we notice a color change, and that is going to give us our final burette reading. We know that the volume of acid used is always our final burette reading. Final reading take away our initial reading. So looking at this, when I am told to fill this table, 24.80 take out 0.00, I am still bound to end with 24.80. So talking about A in this question that we have here, talking about A, the volume of acid used, I was told complete the table, so 24.80. Now, for me to have 24 as the volume of acid used, as the volume of A, not an acid here, as the volume, volume of A, not volume of acid, volume of A used. So for me to have this, that means my initial burette reading, if my initial burette reading moves here, that becomes initial burette reading. The final burette reading remains, volume of acid comes here, volume of acid. So 35.50 take out, see, final reading, 35.50 take out 24, you're going to have 10.50 there, 10.50. Okay, I am looking for my final reading here. For my final reading, if this had moved there, that would have been VA plus initial reading equals to final reading. So this plus this, 6.55 plus 24.10, that's going to give you 30.65. Okay, I have been able to answer question A. I have been able to fill to complete the table. Now the next thing I was told to do here is A2, calculate the average volume of A used. A2, this is A1, A2, volume average volume of A used. Of course, when you look at titration 1, titration 2, and titration 3, 24.80 seems far from the second and third titration. So this looks non-concordant, not consistent. So I'm going to go with this 24.00 plus 24.10 divided by 2. So which means you don't have to use all of the volume of A used. You need to take note of consistent or concordant values. So when you divide this, you're going to get 24.05 cm cube, 24.05 cm cube. That is the average volume of A used. Okay, moving on to the next question. We through with A. We move to question B. Concentration of A in mole per dm cube. B1, Ca in mole per dm cube. Okay, looking at the question from the beginning, A is 0.79 gram of potassium permanganate per 250 cm cube. In other words, based what the information I have for A there, I am meant to convert that into mole per dm cube. For I'm looking for concentration of A, but of course, look at the data I have for A: 0.79 gram, 0.79 gram, 0.79 gram of KMNO4 in per 250 cm cube. Yes, per 250 cm cube, per 250 cm cube of solution. Of course, what this means, concentration of A in mole per dm cube. What this means is very simple: my mole divided by my volume in dm cube. Of course, I am talking about 0.79 grams. So talking about KMNO4, if you try to calculate the molecular mass, were we given in the question for KMNO4, if you calculate KMNO4, potassium plus manganese, okay, potassium is 39, manganese as given from the question is 55, oxygen is 16. Of course, 16 times 4 gives us 64. 64 plus 39 plus 55, we got 158. So this here means mass over molar mass. And volume in dm cube, since my volume is in cm cube, that was going to mean volume in cm cube divided by 1000. So that what this means is 0.79 divided by 158. That's a mole already. That's a mole already. Okay. Volume is 250 divided by 1000 as my denominator. That's in dm cube. That way I have my concentration in mole per dm cube. So this means 0.79 over 158. This is going to go up times 1000 divided by 250 in mole per dm cube. Computing this, what you're going to have is 0.02 mole per dm cube as the concentration of my A. We're moving on from that. Concentration of B in mole per dm cube. I wasn't given any info about for question B2. I was told to look for concentration of B in mole per dm cube. That's the question. But looking at the question on your screen, I never had any info about that. But looking at my B, which talks about the hydrated iron sulfate, if you look at the equation, 5Fe2 plus, so the 5, so number of moles of my B is going to be 5. Take note of that. And the volume of my B from here talks about 25 cm cube pipette, 25 cm cube portion, so 25 cm cube. Of course, my Ca, concentration of my A is 0.02 mole per dm cube. My Na, if you look at the question talking about MnO4 minus, it is 1, and my Va, that's the average volume of A, which we calculated was 24.05 cm cube. With this, using my Ca, I will be able to calculate my Cb. Of course, using Ca, Va over Cb, Vb, that will be equal to Na over Nb. Of course, making CB the subject, this is now going to mean CB equals to CAVA NB divided by VB NA. If we compute this, CA is 0.02 times VA is 24.05, NB is 5, VB is 25, NA is 1. If you compute this, what you are going to have is 0.0962 mole per dm cube, and that just takes care of B. That just takes care of question B 2. Now moving on to B3, we were told to calculate concentration of sulfate ion SO42 minus in mole per dm cube in B. Now B3, talking about B3, what I have is SO42. What I have is SO. I'm looking for the concentration. Moving on to B3, I'm looking for a concentration of SO42 minus in my base here is actually ammonium sulfate, iron sulfate, hexahydrates. So how many sulfates do I have in this? How many, talking about the sulfates from what I have here, how many sulfates do I have? If I try to break this down to SO4 here, SO4 here, that's SO4 2 minus twice. Of course, this is going to mean 2NH4 plus, and then this is going to mean Fe2 plus. That's, but I am looking for the concentration of my sulfate ion. I'm looking for the concentration of my sulfate ion. Now, based on the on what we have calculated before, knowing the concentration of CB in mole per dm cube, that talks about the ion. So you're looking at 1 mole of ion here, and you're looking at 2 mole of sulfate ion here. This is, of course, purely stoichiometric. So I'll be saying 1 mole of iron 2 ion is stoichiometrically equivalent to 2 mole of sulfate ion. So if I am saying 1/2, that's from the equation 1 to 2. Now the concentration, of course, which I have before, that I've calculated for the base, which is talking about iron sulfate for the base, is actually 0.0962 mole per dm cube divided by the concentration of my SO4 2 minus, okay, this moves here, so concentration of my sulfate ion is going to be 2 times 0.0962 mole per dm cube. So if I compute this, this is going to mean 0.19 approximately mole in mole per dm cube, in mole per dm cube, 0.19. But take a good look at the question. That is for B3. We've been able to deal with that. For the next question, talking about B4, mass of SO42 minus in 250 cm cube of B. This is okay, this looks stoichiometric. I was told to look for the concentration of sulfate ion in the base, in B. Sulfate ion, concentration of sulfate ion in solution B. If I dissociate this, I have sulfate, this here, this here, and then this here. This is just the hydrate. Of course, we've been able to calculate Cb before, and that talks about the concentration of the ion sulfate. Okay, now 2 moles of sulfate is equivalent to 1 mole of it. So if I say 1 divided by 2, 1 mole of ion, 2 ion divided by 2 moles of sulfate ion, 1 over 2, then the concentration of this divided by the concentration of this as well. That way I was able to get the concentration of sulfate in B as stated in B3. Now before I mass of SO4 2 minus in 250 cm cube in 250 cm cube of B, as you can see displaying on your screen. Okay, that said, we know that concentration is actually mole divided by volume. If your volume were to be in cm cube, then you're going to have 1,000 here, and of course your mole here represent mass over molar mass. Okay, let your 1,000 be here, mass over molar mass times your volume in cm cube, so that what you have, my concentration, talking about this concentration for my sulfate is 0.19, okay, equals to, what is the mass? That is the mass that I am looking for, times 1,000 for SO4 2 minus, if you calculate that, SO4 2 minus sulfur is 32, 16 times 4 is 64, 64 plus 32, that's 96, so that's 96 times volume in cm cube here, that talks about 250 cm cube. So with this, my mass is going to be 0.19 times 96 times 250 divided by 1,000. Computing this, I am going to have 4.608 grams. So that is the mass of SO4, in 250 cm cube of B. All we have for this probable question has been calculations, and that is that about that. And with that, we've come to the end of this probable question. Do well to subscribe, turn on the notification bell, comment, ask questions, visit us on our website 300plusacademy.com, link up with us on WhatsApp, and let us have your questions so that we can explain better. That way you are better prepared and in a position to ace your next exam. From me to you, it's bye for now.